The best we can do is we can sketch a graph of this function. It can't be exact because we don't know what a is. A is just some positive number. So an example of what the function could be, it could be y equals e to the negative 2x or negative 3x or negative 1x. We know it's got a negative number. So you can put whatever number you want in there and you could graph it in Desmos, or you can make a quick x and y table, which is what we can do if we don't have a graphing calculator available. And you can just plug in some numbers to see what's happening with the graph. So if I plug in x equals 0, and remember this is x, a is the only thing that's restricted to be greater than or equal to 0. X can be negative or positive. So if I plug in 0 in for x, I'm going to have e to the 0 power, which makes 1. Anything to the 0 power is 1. And let's try some negative numbers. So if I plug in negative 1, then a negative times a negative makes a positive. So I'm going to get e to the second power, which would be like, I don't know, 5 or 6 or something like that. And then if I plug in 1 in for x, I get e to the negative second, which would be 1 divided by 2.7 something something. So that's getting smaller. So you could plot those dots. This is right around where 0, 1 could be. And so at negative 1 in the x, I've got a kind of high y value. It's definitely bigger than 1. And at 1 in the x, I've got an even smaller y value. You could find out what e to the negative second is with your calculator. So the sketch of the graph should look something like this. So for which values of a on any infinite domain would you have an absolute minimum and absolute maximum? So they're saying, look at your graph. What value of a could you pick in order to have an absolute minimum or an absolute maximum? An absolute minimum or an absolute maximum is a place where you've clearly reached a peak and you can go no higher, or lower in case it's like something like this. This has an absolute minimum, right? The vertex. This doesn't have an absolute minimum or an absolute maximum because we keep going higher. The range on this graph is positive infinity. It has no limit to how high it can be. And then, the full range in interval notation would be parentheses 0, infinity. So we never reach our absolute minimum or our absolute maximum. Look, it's an asymptote. It's a horizontal asymptote. We never reach 0. So we never have an absolute minimum or an absolute maximum. We get infinitely close, but we never reach it. So the absolute minimum or absolute maximum does not exist here.